Hello everyone, my name is Steve and I want to welcome you to my YouTube channel here for the Atari 8-bit computer system. You can actually see the Atari I have here in the background, my Atari and my disk drive here. And this series is actually used to focus on people who want to learn about basic programming in general. You can also learn about programming in assembly language, either of which you prefer. I tend to take more of a focus on assembly since I enjoy teaching that a lot more. But I do break up sections into where I do show different basic examples and things you can do with BASIC. Like the last one I had on there showed how to do the keyboard and sound and use the get statement to be able to basically read the keys on the keyboard. This session here is a continuation of my Fine Scrolling series. If you watched the original video I had, there was one on Fine Scrolling where you seen me basically taking characters on the screen, and I would be able to move the lines within the characters. I had messages on the screen. You could see the messages scrolling up. The lines were basically scrolling inside of the messages, and I could scroll them up and down and left and right. So basically that's what we're going to focus on here. I've taken this a step up at this time. That video is basically allowing you to scroll within one place, but this video is going to show you how to scroll all the way through memory, and you can probably see here in the background a little bit here. I've already set up my own character set where I can scroll through this in memory, and it looks almost like kind of like a mini maze or something like that. And this is one of my goals, is to eventually master Fine Scrolling, which I've checked issues in Antic magazine from September and October 1985 issues. You can find course and Fine Scrolling examples in there to learn more about it. Recommend getting those PDFs online. Unfortunately, it's very limited on what is found with Fine Scrolling on the internet. A lot of the code that is out there is mostly in data statements, and you have to disassemble it, basically take it and turn it into a readable instructions that make sense in assembly language. Without that, though, it isn't really much use, and you can't really do a whole lot more with it. So this program example, I have actually disassembled this program already in memory, but I have not actually figured out exactly how it works all the way. I'm still in the process of getting that down, basically. Okay, so what I want to do is I want to show you I'm going to demonstrate how it works here. I'm going to go through the little demo here and show you how the scrolling works, and then after that I'll go through the code and kind of explain how this all got on the screen. Maybe we'll do some examples of how to get things to show up in memory and stuff like that. So, welcome to the ride here. Enjoy your stay. Give me a minute to reposition the camera here, as well as the TV here. I'm going to move my camera a little bit. I often regret moving it. Doesn't usually. I don't like it. It's like in the center of the screen now. It's like, okay, if I move this all the way over here, it was going to tilt. It always tilts. I have to repivot it. There's a real sensitive button on the top. You press this one button, it turns off the camera. That happened to me earlier when I thought I was recording and I had to start all over again. Okay. That's about as good as I'm going to get it, I guess. Okay, and then I can move the table here a little bit. That would be helpful. Let's see, if I go this way, getting pretty close to looking pretty good there. Sorry about the delay here, but I think for something to look really good on the screen, you want to be able to see what's going on here. Okay, so let me go ahead and show you first how this works. It uses a joystick. Now this is extracted from another program that I found online, which basically scrolls through memory only. This one, I basically took the characters. You'll see down here at the bottom these funny looking characters. The original one just shows all numbers showing up in memory because you're basically scrolling through memory locations that don't have any data in them yet. And I fill them in to make them look readable. I mean, it looks like an actual maze here on the screen. You see there's actually little aliens here I put into the little mini adventure here. And there's a character set. This is a player missile graphic, by the way. So he doesn't move, he's stationary. At this time, I haven't found any reason to want to move him because I don't have collisions set up in this. It's just an example to show you how to take and start creating your own character set, and also be able to read it in memory and find out where it's showing up in memory and make it appear on the screen while you're scrolling through that memory. So that's what I do. So I kind of move the joystick here. You see it can scroll up and down, by the way. This section here right now is not pointing to any memory where I have any character set up or any data that looks readable at this time. I've noticed that these areas here seem to be in other areas outside of the range of where I'm trying to read my data. So I have my character set up at memory location, I think it's 30 or 34000, and it goes all the way up to like 37000. As you're scrolling vertically, it's scrolling through memory, through the pages in memory. And then when you get down to the bottom, when you want to scroll vertically, you wouldn't scroll into the next memory location. In other words, if you're at 34000, which is the very top left-hand corner here, if you try to count down here and you multiply this by whatever 40 lines is here, and it wouldn't take you, it doesn't work exactly like screen memory. You wouldn't exactly go into the correct memory location because it's not actually reading the entire screen. Where if you look at this in screen memory, it would be set up here from, I think it starts at 39046 or something as a guess here, and it goes 40000 if you looked at it with the graphic 0 screen, and it goes all the way down here at the bottom to another area in memory. So you basically would be reading the whole screen to read that in screen memory. Well, since it's a vertical scroller and you're scrolling here, it's scrolling through a lot more than what you're seeing on the screen. So you basically have to add all this data and put them into statements where you can read it into memory, and also have the machine learning instructions know exactly where this is showing at to make it appear on the screen. I know that's a mouthful, but I'll go through the code here in a minute. I just wanted to show you as I'm scrolling here, I can kind of move up and down through it, and it takes a long time to scroll through it. The scrolling probably doesn't look very good as I look at the video over here, but it's actually fine scrolling. It looks very, very good over here. It's real easy on the eyes. That's basically what fine scrolling is, and it kind of adds a realism to the game. Now, I notice this line has been appearing in the code here. This is picking up something in my memory location. So I think what's happened is when I went to try to read this line, it skipped over this line and it just went on to the next one. So it's not erasing what was left in here somehow. But it goes a long way. I mean, this thing just scrolls and scrolls. So it's scrolling through memory right now, but this is all the character data I put into memory that looks like, actual data. So it stops right there at the very edge of the screen here. And then you can just basically scroll back and everything, so it can go in either direction. Like I said, it can't go down, but there's nothing down here. So, but you can't see it. It is a complete scroller. You can go vertical, and you can go horizontal. So let me just kind of move it back over here for a minute. Hoping to get a nice thumbnail on this one. Sometimes if I keep the graphic screen up long enough, I can get a really nice, pretty thumbnail. Thumbnails, which actually shows up in your YouTube videos whenever you're doing a search on the internet. You'll see the graphic picture or whatever, and before you click on the video, it's kind of like a way to get people's attention. And I did that with my game. I actually sat there and played it for a long time so I could get a good thumbnail on it. So I'm hoping to get a good thumbnail on this one, so we'll see. Okay, so we're back here. And these are some other things I've added in here. You can actually go ahead and change the colors here. This is just a blue, and this is a green. This is this is actually a character set I've redefined. These are all redefined characters, by the way. So let's go ahead and look at the code here, and I'll go ahead and break it down for you. Okay, so time to reposition here. Move up. Now I wanted to show you the original program too, because I've actually taken this from this guy's program, who is Kyle Peacock, or whatever you want to call him. And I've actually added a lot of my own lines into the code. Maybe I'll show that at the very end or something. But these lines here, this first one here, this is actually setting up, let's see here, this is the, I think this is the character set. Let's see, graphics 0 restore. Yeah, this is actually setting up memory location here to read back pages of memory, 4 pages of memory, so we don't end up running into the display list and the display missile, player missile graphics, which are the characters you've ever seen in my player missile graphics video. You don't want to start running that area because you'll overwrite your characters on the screen as you're looking at them. So that's what it does. It kind of shifts memory back here, and this just sets up a variable where it stores that the area where we're going to be able to read this in later down here. And I can show you where this, I think I have this code broken out here. Maybe I don't. I can kind of disassemble this for you in a minute and show you the data statements for it. And I think they're actually down here. Because what I did is I transferred them into a string. Anyways, before I jump down here. So basically what it does, it just takes a graphics mode 1 plus 16, which graphics mode 1 allows text and all that, and the plus 16 a little bit, removes the text window at the bottom. And then this is restoring 52, so it's going down here and it's reading this data line. But my program's not doing it. Originally I have it reading the data, so I can read them into this, what's called a character string, so I can execute this because a character string will run a lot faster than trying to read it into a for loop. And I'll show that here. Okay, so what it's doing here, this would be the normal place where it would read it in before I use this immediate action. So basically it goes for L equals 1 to 32. And it's going down here and it's reading this data, so let me go down here a little bit more. So these are remarked out right now, so these aren't being executed. But I can turn these back on and make it read basically back into here, and then turn this back off so it'll basically read the data in here. And the reason I did that is if I need to go in and change anything within my assembly code, I don't have to sit there and go pick it out of this string looking characters here. Because these characters you see right here is actually exactly what you're seeing down here. And I'll show you that in a minute, but let's see here. So it's basically reading in the character set. It read P, so it goes for L equals 1 to 32, so it's going to read in 32 bytes in memory. So the first thing it's doing is it's reading P, which is the first number, which would be 104. And once it starts getting these numbers, it starts storing them into a string I set up here, which is just called bytes, because it's reading in bytes, I called it. And it's L comma L, so it's basically taking this for loop, and it's just starting to read these in one by one. So it's basically going through here, and it's just reading these in. See what it says bytes here? This is bytes 1 comma 1 bytes. I think this is 2 comma 1 if I'm not mistaken, 3 comma 1, 4 comma 1, 5 comma 1, 6 comma 1, until it gets all the way up to 32. And then it reads them into a character string here. Notice down here, when we're originally reading these into the data statement here, they're actually numbers here, but up here you see characters, and I wanted to kind of pull this apart right now and show you why that is, and how you make that translation. So what I'm going to do is I'm going to pretend I'm reading in, I'm going to set up a loop, and I'm going to read through this character string I set up here. And if you don't know what character strings are, go ahead and watch my video called Atari, Atari Keyboard and Sound, because it explains them a little bit more. I have one example where I explain how the character strings work. Okay, so let's see, current axis, bytes, I'm doing this correctly. Let's see if I didn't make a mistake here. Okay, so basically there, what I just done is I took apart this byte statement you had here, and you're seeing the same data that you saw earlier. So it's basically translating this into characters. Now if I turn this into the character, which you saw right here, where's that? Equals CHR string, because it's reading this into it's reading the string into a character set. I'm sorry, not character set, a character string. You'll see a difference here. Now I'll go ahead and I'll change this up here. Let's erase this. I don't think I can do this. I'm going to try this anyway. Let's see. No, that's not going to work. Okay. Just going to read in the regular character. Let's see. Character X comma X. Oh, I know. I can do XC bytes. what I'm trying to do right now is I'm trying to get these characters to show up exactly as you see them there. I can probably just read them into the byte statement. I don't know why I'm going through all this. They're already in there, so let's just do it that way. Let's try to convert them. Go right there. Oh, I'll do around here. I got an extra semicolon. Match up your semicolons. I had an extra one in there. Or parentheses, I'm sorry, open parentheses. Okay, so there you see it. Now, if you look up here, I set commas in here, and this one I should take this out so it doesn't separate them with commas. I separated the comma earlier so you could see the numbered data instead of the numbers all running together. Let me go back and just make it look like up there and take this out. There we go. Now you see that they're duplicated to what you're seeing up here. Now I wanted to translate how these are shown into these number statements, so I'm going to also show you the data statements underneath this so we can kind of do a comparison on them. Let's say actually value bytes. You're looking at there. So now what you're looking at here, this data represents these little characters you're seeing here. Here's how this works. I've showed this in another video, but to kind of keep this one in sync, I'll kind of go over this recap on this. First of all, the information I'm getting this out of is the Atari. Well, this is an XE system I used to own. It's the owner's manual, but you can get the PDF online. Just go to the back of the book for Appendix C. You'll see here at the back it'll say Appendix C. Yours may vary, but mine is Appendix C here. And you see, look right here, as soon as I get a focus here, you see these characters going down the screen here. You look back here, that's what you're seeing here is these characters right here. So these are called AXE characters. You look up here, it says AXE character set. So basically it's taking these characters and it's showing you what the decimal code is. So you look over here, you'll see numbers here that correspond to the characters you're seeing here. And in this example, what we need to be able to do is we need to dissect what the AXE character for 104 would look like. It is right here, but I wanted to show you how this actually equals 104. So you just go in the book here and you look for that visual character for the lowercase h, which is right here actually. I'm going backward here, let's see. It's right there. You see, look over there. It says H. And you see 104, viola. So that's what we got here. We got our first character, and you see that there's two H's here. So two of these H's is going to correspond to 104, 104. The next symbol here, what we need to do is, this funny looking character would be harder to look up. So just basically look up the number, which is why I printed them down here. So I'm going to look up 133 in here for that decimal code. And I got it down here. Oh yeah. Right there. Look over there. You see that character? It kind of has a little hooked or something that's showing to the right there. And it says, look over here, it says 133, right? And of course, 133, and you got that hook character. I'll show you a few more of these, but I think you'll probably end up starting to get the hang of this. Next, we're going to look up 213. Just go through your book, or go through your, you can get these PDFs online too. A lot of times I have references, links on my YouTube pages for each individual video to make it easier for you. So we're looking for 133, and it'll look like this U here. Hope you can see that. It looks like it's an inverse U. Inverse means that you've gone ahead and you press the inverse key and it changes the background coloring of the text in those bits. Okay, so 213. Right here, U. And see it's an inverse, and it's 213. So I'm getting the hang of this now. So what you're looking at is 104, HH, 104, 133, that hook, inverse U. Now look at the next one here, 104, and you see the little H again. So you see that these are copying exactly what you're seeing over there. So these are translating into the assembly instructions that are actually allowing this instruction to take place right here. Up here I have it immediately set up in memory. So I won't go through this whole example, but if you want to, you can use the book and kind of go through them line by line there. Hopefully you get the gist of it. It's just basically translating our data that we read in earlier into a string that could be executed and ran with assembly code, whatever you have the instructions doing inside of here. And the reason why this is helpful to set it up on a line like this instead of using a for next statement here, because notice mine is commented out with the remark statement, is it'll execute this line, it'll execute your code faster because it won't have to take each individual L from 1 to 32 and count from 1, 2, 3, 4 until it reads in 32 times. Now if you have a bunch of for loops, if you have like 5 or 6 of them, it's got to go all the way through those before it gets to the next instruction. And a lot of times you'll see messages on the screen like initializing, please wait, or something like that. So basically it makes the program run slower. But when you learn how to set up these in immediate mode, like you see right here, you can just have it go right through the code. In seconds you'll be bypassing all these for loop statements. So hopefully that made some sense, but it's just a lot faster to put them in strings. Although you might think it's tedious to kind of go ahead and look up all these characters. I'll show you another shortcut, and I actually did kind of show it to you right here earlier. But I'll show you on an intermediate line how you get that whole thing read in. Since you've gone ahead earlier and you've already read this in right here, where's it at? Right here, you read it into a string, L, L. It's already stored in memory in this string. So basically you can just print this string to the screen, and I just end up just copying it on the middle line like this. So what you'll do is go up here, we'll save some room here, and you'll just do question mark or print bytes. And then you just basically see that line going there on the screen, and then you just go in front of it here. I'll add another line even though we don't need it. You just go like 32. I'm just using the insert key here. You just basically hold Control and you press Insert, and it shifts the text over. And you just type bytes equals quote backspace. You hit the Control key and you hit the delete key to bring it back. And at the very end, you just add another quote and hit Enter. And there we go. And you list the program there. And you see my new line is now in the program. So it saves you a lot of time trying to look up all this garbage, if you would. And it saves you having to translate all these data in, because basically if you're reading them into string, they're already stored in memory. You just have to print them to the string and just add them to a new line number. So the shortcut. I'm gonna erase that one because we don't need 2 of these in the program. We'll override the other one. Let's see here. Okay, so now that you got that, you might well, let's see, we're going to go into the next part of the program. So what this is doing now is this is going to be reading in character set, the characters you saw earlier on the screen. Oh, you know, I forgot to almost explain what this one does. This code here, this assembly code, I think this is the clear screen or something. Let me see. Let me go back and look at this again. See what this is doing. Or the instruction for it. I saw it somewhere earlier. Where'd it go? I'm looking for a USR instruction. You guys probably already seen it here somewhere. I'm not finding it yet. I don't think I deleted it. It might be down here. Usually it'll look like this, where you see T equals USR, and it'll say address of bytes. I must have deleted it or skipped it or something here. Hopefully I didn't delete it. I still got the program in memory. I just have to rerun it. I just don't know what happened to it. Unless it's just executing down here somewhere. Maybe it's just executing down here. Let's see. Okay. really weird. I'm just going to load the program in. I don't know. It's supposed to be able to do a USR instruction here to be able to read this code in somewhere, but I don't see it in here anywhere. I just see the number statement, and I'm just going to reload this to make sure I didn't erase anything. Unless this is somewhere else in the program. Actually, I did erase it. There it is. It's on line 32 because earlier we overwrote it with the byte statement. I wasn't paying attention. So it's going to take this and execute the code we saw earlier, and it's going to find the character set. So this is basically, if I'm not mistaken, this is actually, I know what this is doing. It's clearing out the character set in memory at a faster rate. Because if you had to read through this character data, you're going through pages and pages of memory. I don't know how far it goes, but if you had to go through so many thousand of pages here, you would do something like a poke statement, 57344 plus peak. I think this would be something like ACT or something like that. So basically, what it's doing is it's taking a whole for loop statement like this and saving you time by using a fast assembly instruction to go ahead and clear out that character data in memory. Because when you read, oh, I know it's not, I'm saying clear. What it's actually is, it's moving your character set in memory. So basically it's doing it at a faster rate instead of having to read it in byte by byte right here. It's going to do it in instructions. So let me just double check my code here and make sure I'm not shooting myself in the foot here. Let's see. So pull, store 203, store 212, load the X register 4, load Y register 0, and it's load 0 page Y 212, store 214. So let me just translate what this is right here. It's going to get the high and the low bytes here. I'll show you what I'm getting at. So I'm basically taking this line number right here, 213, and this number over here, 212, and I'm trying to determine, see if this is going to show the high and the low bytes of memory. And that looks correct. So basically it's taking the character set and it's moving it in memory. So it has to move it into a higher location in memory. Because 57, I think it's 344, is where the regular character set for your ROM, your characters you see here on the screen, like the RE, and all the stuff you're seeing on the screen is actually stored in memory at 57344 if I'm not mistaken. And you can't write to that area, so to be able to redefine the character set or move the character set, which is what this one is doing, you have to basically set up another area of memory where you're going to store it at. So it's basically taking a series of the loaded instructions. I don't have these translated, but it's moving them in memory. So let's go on to the next one. So this next one here is actually going to read the next lines down. So keep in mind, we just went through all these lines I was showing you earlier. These are our bytes, by the way. Once we've gone through our bytes and we've executed the instruction, it's already used that assembly instruction. And the next part of the program is going to read in our character set here, which falls right underneath this. So you go up here, it says for L equals 1 to 5. So what this is doing, when you do a read CH like this and you're doing it and you're embedding it inside of your code here, because we got a next L embedded inside of a T, it's going to be reading these things one after one. So what it does, it goes for L equals 1 to 5. So the first time L is going to be equal to 1, which is going to read the first statement down here after we're done with this, and it's going to read a 1 here. And then it's going to say, it's going to store that in a variable. So now CH is equal to 1. And set equals CHACT plus CH times 8 is this basically taking what we initialized earlier into the CHACT. We can get that by printing here, but let me find out where that started here. Right here was initialized CHACT equals mem times 256. And let me just print that on the screen and see what the value looks like for that. Oops, I think we had to run the program again. And find it. Let me just get it past the first reading part. take a little bit longer. I wonder if I changed anything in this. Uh-oh. Looks like we just locked up here. I must have, sorry about that. I must have gone in and I changed something in the program and I tried to execute assembly code that wasn't there and it went to the wrong area. So I'm going to basically have to go ahead, to my surprise here, and boot up DOS again. Being unprepared, I don't even know where my DOS disk is. Here it is. That's what you call a lock up there. When you hit reset there and you can't type anything on the keyboard, your computer's basically gone into a no man's land. So just reboot it. We've already got the program in memory though. That's why you should always save when you're working in assembly. And if you're ever doing real long basic listings, make sure you save too. Especially like if you have a power outage or if something goes wrong with your code too. Sorry for that distraction here. I wasn't ready for that. What I get for tearing it apart. There we go. Okay, so back to where we started. So we've already got the first number read in here, which is the 1. And I was just trying to show you what this value is. So if I run the program, I can show you this value. I think it's 57,344. Let's try that again. This time it'll work because we didn't go ahead and modify anything. Hope I'm using the right program here. Doesn't look good. I didn't save this. Maybe I've got the wrong program here. Let's see. I know it's smooth 1. Smooth 2. Wow, what is going on with me today? Unexpected here. Let's find out what's going on. I did not even do any saves here. Now my programs do not even want to load in properly here. So disappointing. You saw it working earlier, and I'm like, where did it go? Do I have like another disk here? I'm getting the wrong disk or something? I don't know. Kind of looks correct to me. I'm gonna go back and double check it too. Well, to save some time, I'm not going to go ahead and try to run this and show you what the value, but basically it's reading in 57,344 and it's setting it equal to your lower range 4 pages in memory here, multiplying by 256 to get a starting place where it can move that character set. So back down here, the next thing it's going to do after it's read through this variable and calculated where we need to put it at, it's going to go to a new for loop statement here. So this is looped inside of this, so it's just basically jumping down. Instead of going for L equals 1 to 2, which would be normal if you had a next L after this, since you're embedding them, this is going to read the next variable in sequence here. So basically looking at it from an up and down view, I guess you could say. So now T is going to be equal to 0, because first time we read it, and it's going to have a B here. And if you had to guess here, which numbers do you think it's going to read? Do you think it's going to read this 0, or do you think it's going to read this 2? Keep in mind, earlier this 1 was read by the L up here. Excuse me. I'll give you a second to see what you might think. Okay, so the answer is, what it's actually doing is it's not reading in the next byte in memory, because we've already got that line set up here from 1 to 5. So what it's basically doing is it's reading these into the L, and these T equals 0 to 7, it's reading all these data. So actually, I'm sorry, if you said the 0, you are correct, because it's reading in the next byte in memory. And this is going through here all the way through this loop. So if you look here, it says for T equals 0 to 7, read B, it would be 0, and then it's going to poke in the area where we located our character set. It's going to add it to T so it can pick up the individual characters that you're adding in here, and it's going to read B, which is the number. So it's basically taking this and storing it in memory here, so we could start moving. Since we've already moved our character set into a safe place, we're now building those characters you're seeing on the screen here, like the maze and all that, which I know for some reason it's not running. I might not get it to run here again. Kind of a bummer, but okay. So next T, so it's basically, it'll read the whole line here. So if you count here, it goes 0, 1, 2, 3, 4, 5, 6, 7. So it's just basically read this in on the first occurrence of T there. Now, the next thing it does, instead of going back and reading this 0 or this 2 into the T, which would not be correct, it just goes back up here, since it's already completed this for new statement here. It goes, well, it goes down through here in the code here. I've got this on, I notice I have this little line inside of here. I could probably move this outside of here, but it'll set a position here, 3, 8, and it's going to put a message on the screen saying scrolling demo. But then it says next L, so what it's doing is it's jumping all the way back up here, and now L is equal to 2, because earlier it was equal to 1. And read CH, now what it's doing down here is it's going down to the next line, since we've already completed 0 to 7 right here. So what this is basically doing is it's telling me which character do I want to initialize in the game. So I want to initialize character 1, 2, 3, 4, and 5. And I want character 1 to look like this line here, which I don't know if I have an example here. I can show you this real quick. This probably isn't a good example. I've shown this in other videos here. There's nothing in this one. But you see all these squares here. Basically, it's reading in these squares and it's filling them in to make them look like characters on the screen. And that's what these are doing, is they're building what the characters are going to look like. And I think it's over here. Just grabbing my graphs halfway across the room here. So you see this first line that shows 0, 251, 251. It's actually right here. This is the same data I've used for my game. Right there, 0, 251, and it's just reading in this first one. This graph 2 is just this one right here. And this is reading in, maybe not all these characters, I have some of my own made up characters here. And this is reading in the characters so that you can put them in and redefine them and make them look like what you want in the game or demo or whatever. So now we got that. Okay, so once we completed all this reading in, remember the for loop L has already executed all the way up to 5, from 1 to 5, and the T is gone all the way from 0 to 7 since it's going through line by line here. It just skips over the data statement since they're done here, and it goes into this poke statement. Now 756, mem is where you want to find and point to in memory where you put your new character set. So this mem up here earlier, you might have saw it in the example here. It was just redefining where our new memory would be found for our character set. And I wanted to show this. I've showed this in other videos, but in this book I have, The Map in the Atari, one of your best resources for really taking full advantage of the Atari when it comes to memory. If you look here at memory location 756, it says character base register. You can ignore that line right there. And I can tell you what that means, that it's a little bit over the range of this video. The default initialization value is 224 for uppercase characters, blah blah blah. Let's see if we can get down to anything here. How do you create an altered character set? First, you must reserve an area in memory for your set. 1024 bytes. Look at location 106. You saw us use that one earlier. Then either you move the ROM, that was done in assembly earlier, or half set if that's all you intend to change, into the area and alter the selected characters you see down there, or fill up the space with bytes which make up your own set. Then you poke right here. Then you poke 756 with the MSB, or the most significant byte of the location of your set, so that the computer knows where to find it. And that's basically what we're doing in this instruction. Okay, so the next part here, we're transitioning to now. We've already redefined the character set. Now we're going to set up our own player missile graphics. And this is not actually my code here, but this code example is actually found in this book here, which is the one, I don't know if I showed this earlier, it's the owner's manual for the Atari XE system or the Atari computer. And there's a program in here, this one's on page 63, it's called Players and Missiles, and it just allows you to go ahead and set up your own player missile graphics. I just changed the colors, and I changed the location of where the character is going to appear on the screen. This one says for A equals P0 to P0 plus 128, and in this one I have him going P0 plus 20 to P0 plus 27, because in this example where it says, I looked at the wrong line, I think. Let's see. Oh, there was one below that. I'm sorry. So let's see here. It's right here. The first one here is clearing out memory. Right here it says finding your character set, which is stored in P0 right here, which is the player missile base. And the second one here is going to read the location of where he's going to appear vertically, where it says plus 60 to plus 6 plus 7. These data statements here are redefining the character in memory, which is that little pink alien you saw earlier on my screen, or red or whatever color it was. And this is going to position him down from 60 vertically to 67. So it's positioning him down 77 bytes in memory, since that's the length of the character. And here I just have it set to 20 to 27, which is still 7 bytes, because 20 to 27 is still 7. And this is going to position him further up the screen, because in this example, in this book here, the alien actually appears in the center of the screen. And I don't want him in my example, because if he appears in the center of the screen, he's going to be already outside of the map that you saw earlier. So that's basically all that's doing, is it's setting up this is called the low memory pointer, so it can find a safe place to put your player missile graphics. And this is getting the high and the low bytes here. I think this is the low and this is the high right there. I would get those two confused. And this is poking 54279, comma, player missile base divided by 256, which is the initialization of where the player is going to appear in memory. So let me look that location up here just to kind of explain that. I did explain this in my, if you watch my player missile graphics video, I did go over and explain how, it's a different example, but I've explained how the player missile base works and everything, and using the map in the Atari book to look up these locations. But I will look it up for them for your convenience here. To be fair, let's see, 54279. It's right here. So, we're done here where it says PM base. It says MSB, most significant byte of the player missile base address used to locate graphics for your characters and or players and missiles. The address equals, and it shows you the calculation, player missile base times 256, which is 1 page of memory. Player missile graphics are tricky to use since there are no direct Atari basic commands to either create or move them. One of the fallouts with the Atari, basically. And however, commands for player missile graphics in basic A+ and C++, basically you can create them in those languages. Let's see, your player missile graphics must always begin on the 1K or 1000 byte boundary. And this was here says peak RAM top. It shows you how to go ahead and put them safely into the 1K area. And this is a -4 for a double line, or 2K, which would be -2 here for the 2K boundary. So basically that's all that's doing, is just setting up an area where we can safely locate them to the screen there. Okay, so the next line here, 543277, I think this one is the collision, but let me check. I'll have them always memorized. I used to. Yeah, this is actually the collision. If you look in the book here, I didn't show this in the player missile graphics because my original doesn't use collision here, so I'll read this here. Wait, am I looking at the right one? 53278. Oh, 53277. Oh no, it's not. Okay, so I'm right. It doesn't have collision here, so it's just saying used with DMACTL, which is actually somewhere else in this book here. Let's see. I think it's at 559. I'm guessing the location here. I'm going to kind of skip around the book and show you where that DMACTL it just talked about. Because some of this stuff, you read it in here and it kind of like is jargon. It's like, what is this DMA-CTL? I mean, if you look here in front of each memory location, you'll see there's a code for them. And this one that says DMA-CTL is just one of these numbers found in this book. And I have it memorized. I'm pretty sure it's 559. I might be wrong. That one is actually showing SDM-CTL. I guess I was wrong. Unfortunately, you can't look them at up in the back by the codes. But boy, oh boy, I think I shot myself in the foot on this one. I don't know where it is. Let me see what this is actually. Let me just go ahead and read through this a little bit, and I can probably make some sense of this. Oh, it actually told me right beside it. It says 54272. This is what they did actually locate it. So 54272. I was nowhere near it. It's actually up here. It sounds like a shadow register. 54272. Sorry about this redirection, but I wanted to show you where they're getting this. It's right here, or 54. It's 277. Excuse me. 54272. Right there. So, notice that you can't look these codes up in the back, but this one is saying direct memory access. It is also used to define 1 or 2 line resolution for players to turn on players and missiles. Values are poked into the shadow registers at 559. That's why I thought it was 559. Apparently this is the shadow register and this is the regular location, and are also described there. You poke the shadow register with the following numbers in order to turn 0 is turn off the playfield, 1 is use narrow playfield, and it goes here on the back, and you see 2 is use normal playfield, wide. So basically it's setting up the excuse me, it's setting up the, they would say the resolution. Let's try to read here. Find 1 or 2. Sounds like it's setting up the resolution of how the player is going to appear. Because if you change those numbers, 53, 277, you get different funny things that make your character look kind of different. I've seen that happen. So I think it's just relocating where they are in the shadow register or something. Let's see. So we were at 53, 272. Let's jump back there to get back on track. But I think now you know how to go ahead and look up those codes that you see found in this book, which are pretty common. 272. Was it 53? I'm looking at 53, 277. I'm looking at 53, 272. Okay, so right here, back where we are. So basically, it's used with that resolution register to latch all stick and paddle triggers to joysticks. Now this one probably won't make much sense, but if you go down here, it says to revoke player missile authorization and turn off both players and missiles. Aha. Poke 53277, 0. So right there is what it's doing, is it allows them to turn them off. Once last triggers will give a continuous button press. Read the first 10, they are red. This gets kind of into some other more advanced concepts here. Bit 7 is restored to 0. Triggers are placed in latch mode. I have no idea what that one's doing. Let's see, have you ever hit break during a program? So this is basically defining, I guess you could turn them on and off with this register, and you can do other different things. You can set up the resolution or whatever this is doing. So it's just used in your player muscle graphics to get them to locate correctly. And here's the one I was talking about earlier, the 559, 34 plus 8. Let's jump over to that one. You can get these PDFs online too. I usually put them on my page. So 559 here, the code is SDM-CTL. It's direct memory access. Poking with 0 allows you to turn off Antic and speed up processing by 30%. That'll speed up some of your basic processing that's going on. Of course, it also means the screen goes blank, so you won't be able to see anything when Antic is turned off. So if you poke this with 559, 0, it'll blacken out the entire screen. That's basically what that's saying. And let's zoom back in here. Alright, so where we at? This is useful to speed things up when you are doing calculation that would take a long time. While handy to turn off the screen when loading a drawing, then turn it on, blah blah blah. When you get down here, the location. There's a shadow register for 54272. That's a little bit more advanced for assembly. and the number you peeked above defines the playfield size. So right there, it's the playfield size, whether or not the missiles and players are enabled, and the player size resolution. Maybe there are options. Using PokeBot 59, simply add up the values below to obtain the correct number to poke into STMCTL. Note that you must choose only one of the 4 playfield options appearing in the beginning of the list here. And these are the numbers of how you go ahead and set up the playfields for that. So this right here is no playfield for decimal. So poke 59, 0 is no playfield. Poke 59, 1 is a narrow. Poke 59, 2, and I'm probably doing this wrong, just to add these up in what does it say again here? Add up the values below to obtain the correct number to poke into SDML. So I think what it's doing, 32 plus 5, 16 plus 4, I might be wrong, but that's what this is doing. It's also another way to get them on the screen, because if you don't use this and you go ahead and just run this code without this, your player muscle graphic won't even show up on the screen. If this was working, I could show you. It'll just basically show a bunch of funny moving lines on the screen. You won't even be able to see them. And this right here, you've seen this in my other player missile graphics video. This is initializing the area where you want to set up your player missile graphic in memory, starting at 512. I don't have the book here. I think it's already on the other side there. But this sets up the player missile base where it's found in memory. I'm running out of time, or I would go grab that book. So watch the player missile graphics video and you can get a better handle on what these lines are doing right here, because I'll explain that better. So basically, you're setting up the player missile graphic, you're poking them into memory here. You're setting them up at the Y coordinates here, which I explained earlier here. You're setting up, what's 623? I don't have these all memorized, excuse me. The priority selection register, I think this is whether they can pass behind or in front of the player, so you can make them go behind objects and in front of objects. This is the color, so we're setting it up to, I think it's an orange color. Our man earlier was an orange color. And this is the character right here, it's being read into memory. So when you saw that man character at the top there earlier, this is the data for it, and I might even have it on my graph here. Let me look. I think I pulled it right off my graph or somewhere. I don't recognize this 2424. Yeah, it's actually right here. I think it's 860. Yeah, it's this one right here, actually. Sorry. It's this character right here, 24, 860, 24, 28, 30. So right here. So earlier when you saw that orange character, that's just what that's doing, is reading that player muscle graphic on the screen. The video is going to go over if I'm not careful. Okay, so next line here, this is doing very similar to what you saw earlier. It's just reading in a character string. This time we're going to read it into our own area called fills. So this is going to basically erase character graphics in memory at a faster rate. Instead of doing it through basic, it does it through assembly. And the reason why I say faster, again, those who may argue, well, you got a for loop in there, even though this one is marked out. If you didn't have this and ran it with a for loop, it's basically, I have it run it in intermediate code, and I think that's why this one didn't work, because I don't have these two set up. I think I found it. So I tried to execute the USR instructions earlier, and it couldn't find us. I'm pretty sure that's why that one wasn't working, but we'll try it. So it's going to execute this code here. It's going to clear out the player missile graphic, and this other one is going to fill in. What does the fills do? Let's see, fills equals 0 to 29, 32, 768. Oh, I know this one. This is actually my own routine here. The second one here, I'll show you this in an example. I created this. If you recall the program earlier when we ran it, when earlier you saw the demo running and you saw all those little blocks on the screen for the maze, I had to draw those into memory instead of trying to poke those in individually and setting them up in data statements. I just created my own assembly routine here, which is actually found right here. Hope I got the right page up here. Yeah, this is it. And you see where it says load the accumulator number 208, 203, and you see this number here, 53770. That's a random number. So it's picking a random area in memory It's going to end it with 32, so it's going to mask it at 32. It's going to skip an instruction in memory and store it in the, to basically high and the low bytes up here. You see where it says fills merging character with random, random areas. So basically, if you look down here, this is this is the reading into memory. So it's basically going through memory and it's starting to fill it up with the character that we selected here. And then it's going to increment the next high byte in memory here. It's going to decrement the X register because here it was set to 23, so now it's 22, 21. So it's basically what you're seeing it doing is it's moving those. It's just a faster way of taking characters on the screen and moving them randomly in memory so that they're not positioning one after the other. So basically, with that AND instruction, it's skipping areas in memory where they can appear on the screen. Now I'd like to run this and show it to you again. I'm afraid it's going to lock up. I'm going to chance it. Maybe even save it. Because I'm pretty sure it's because it didn't find these USR instructions. Because if you try to run assembly and it gets to this line down here and it can't find out what goes into here, it's going to blow up. Hopefully that would have fixed the problem here because it was running perfect earlier. Earlier I might have gone out and taken the remarks out of these too. I might have not caught myself doing that. Let's see. It's going to take a minute to save this. It's going to be a long one. Might make this one an hour and a half. We'll see. It'll be it for your enjoyment. Let's take a chance and run it. I'm going to keep my DOS disk nearby, just in case. And I won't run this one again if it doesn't lock up. Hopefully that doesn't lock up on us. I'm going to show this so badly. Let's see. There it goes. So earlier I wasn't able to read in our fills and our, was it declares? So now it's able to read in those immediate instructions. So it's basically able to drop down to the next lines of code. So it's going to work now. And I can show you what I was just talking about with the random fill. Okay, excellent. Okay, the only thing is this player missile graphic, it didn't clear this out for some reason. Sometimes when I run it, it doesn't clear it out correctly. I just need to fix that. But that is the player missile graphic there. And when it's using the instruction you saw earlier for the, the clears or whatever, it'll basically clear out that player missile line here. So you don't see a bar underneath and on top of your character. Otherwise you'd be running across the screen with a bar and your character inside the middle of it. Or funny looking graphics depending on what's sitting in memory at that time. So what I wanted to explain is this code I showed you earlier here, where I was reading in the high and the low bytes and reading in a random area and masking it at 32 and incrementing. What it's basically doing is it's repositioning these. You see all these little green blocks? It's repositioning these all the way through memory here. So as you saw me earlier when I scroll on, it's this assembly instruction I did is filling this whole maze with all these random blocks you're seeing in memory. Because like I said, if you had to do that in data statements, that would take a very long time. So I found the faster way to do it was just create my own assembly routine and just kind of set up a weird looking maze. I know it's not navigatable because some blocks keep running. I just did this just so I could see all the data in memory as it appears on the screen here. So like I said, it goes all the way over here. You've already seen me go through all this earlier. I'm glad it's working. You know, our player missile graphic looks funny. Okay, so basically you see it reads all the way over here in memory. So to go back and dissect that for you, let me just do it on the screen here and I'll show you back on the screen here. 208, 132, 56. So, where I got that from, back to the tablet here. You see here at the top where it says load the cumulative number 208, stored in 203, and it says load the cumulative 132, stored in 204. So remember the 208 and 132. So basically what you're doing is you're calculating the high and the low bytes here. And this is not picking this up very good. I'll change the background color for a minute. Oops. Okay, so that's basically what it's doing. Come on, camera. Is this positioning in memory? Because I don't know if I mentioned this in my video earlier, but my memory is starting from 34000 and it's reading all the way over to a long range of memory, however far that goes over vertically. So it's basically what I'm doing is I'm reading at 34000, and we're starting to set up those random plots in memory as it's going along, and it's plotting all of those little bricks you saw in the maze. So it's just a faster way to do it. Go back to the code here. We're just at an hour. Wow. This is going to be a long one. My videos do exceed an hour, so we can keep going on here. I guess this will just be a special one for you, if you enjoy this kind of thing. Okay, so like I said, we left off here where it's basically executing the clear statement here for the code, and then it's going to execute another assembly instruction for the fills, which is the random blocks you saw earlier on the screen. And to explain earlier, if you didn't understand, when I tried to run this program earlier and it locked up on me like that, and I couldn't get on the computer, had to reboot it and put DOS in again, I didn't have these lines in here. I mean, I did have them in here, but I had a command called REM in front of it, which stands for remark. So basically the computer was skipping these lines, and when it got down here and it tried to execute an assembly instruction, it didn't know where to go, so basically it goes into no man's land and just crashes. So you always want to make sure that your assembly code is also correct and it's able to jump out of the loops properly, otherwise that'll cause a lockup too. This one just caused a major lockup because the computer didn't know where to go. It was executing its own called a relocatable memory address, and it might have just sent it somewhere else in memory to crash the program, to crash the computer. Let's see, down here for A equals 1 to 32. These were some original stuff I was doing. I'm going to remove these lines. I originally had this filling in memory area, so I was basically trying to draw. You saw that block maze you saw it going around, the blue bricks going around the maze there. I was just drawing those in that way in memory. So now I have them set up on a different line here for A equals 1 to 352. Remember, it started at 34000. So notice this one is saying poke 38608 plus A. So you got to figure out where would 34 be from 38. So if you look at this in memory, basically what it's doing is we would start all the way at 34000 at the top. So as we're scrolling all the way through the maze, when you get all the way to the end and it stops, this is where it's drawing in this character. You probably didn't catch it earlier, but there was I think it was a line going down there or something. It was drawing another set of bricks or something. And these are just poking in different areas of memory here. 5 plus 160 plus 32. This is taking the redefined character we had at 5 and is poking this in memory. So I think this is that pink alien you saw earlier. I didn't comment what these were. Let's see, 160 plus 32. It was probably the pink alien. Let me look at the graphics for that pink alien. He's 6126. I think I'm right. Yep. So earlier when you saw me holding up this book right here, and you saw these data statements down here at the bottom. So it says 60, 126, 153. Oh, losing focus here. 255. There it goes. Now you can see them right there real clearly. So basically that's what it's doing, is it's reading in character 5 there, and it's positioned those aliens on the screen. Now remember the 5, go back down where we were. You see it's right here, 34, it's 5 plus 160, which is going to represent the next highest location in memory where we can change the color of that character. Because as you find different areas of memory as you're poking in screen memory, you can start changing the color character from defaults are orange, blue, green, and red. So this one was red, and I just changed the color here. I think it was earlier up in the program. It might be down here. And these are just basically positioning those characters. This one I did mention here is the bottom wall here. I was drawing the bottom wall on the screen. Oh, I had this line remarked out, I think, under this, it was remarked out. A equals 0 to 6. So these are just different areas where we can go ahead and just poke in different things in memory. I wanted to kind of demonstrate that here for you and show you. We'll set up our own little line here. Let's see that we don't run into anything. Let me see. I said this is going to be an extras video, so excuse the length of this video. I'm going to set this at 214. We started at 34,000, so I'm just going to multiply this by maybe, I don't know, or add 5 to it. And we're going to, I'm going to see if I can position my name in here. I don't know if that's the right XC character for it. We'll find out. Five plus 1 to get one place over from the name, so you can put the next letter next to it. You can also just do this. 5. You can say this one's 6. Oh, 6. A little bit easier to understand, maybe. This works correctly. It should print my name, but it might end up printing some funny looking characters on the screen, but we'll find out. Let's say I got 5, 6, 7, 8. Good to me. Unless I made a mistake here somewhere. There it goes. Okay, so it's just gonna, this works correctly. If I've got the right correct AXI character, it should show my name. Otherwise, if it doesn't show my name, when you look here at the top, when it runs, you're going to see some characters here at the screen. Whether it's going to show my name, it should show 5 of those new characters, whatever I just put in here. So it's just basically reading these out of the AXI character set in memory. So let's find out what happens. Take a minute to run it. This is kind of demonstrate how you get memory poking in area, or how you get characters poked into memory and how you can get them to display on the screen. Okay. You see them? Look here at the top. These are our new 5 funny looking characters. They're not my name. So basically S, T, E, V, E. Notice the E's are the same, so it's basically reading in the same character here. So you could tell it's working, it's just not finding the right AXI character, which I think I just have to start in at 33, which is A, and locate where the S is, the T is, and all that. I do have a book. Grab it real quick just to show you how to get my name up there. We'll get this working. Show you that it does work. You can actually poke into memory. You can also poke into higher locations here down further in the maze. You don't have to just poke on the screen. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So maybe if I poke somewhere down in 30, we'll make it show up when we scroll through the screen. I'll just do like 40 or something like that maybe. Looking up the AXI characters for the screen codes for these. There's another book I have. It's Basic Atari Basic. You can probably get the PDFs for this on. And if you look at the back here, this is our AXI character codes. You got the same thing, but you've also got some extras with this one. I think this is the right one. Let's see here. Let's see, decimal code. Maybe it's on another appendix. Let's see here. Oh, actually, you know what? This is reading in the screen AXI codes. The other one reads in the regular AXI codes in the character set. But if you look over here, it's going to be different than the one I showed you earlier. Where am I at here? I'm looking for my name here. See it there at the top? It's S. It's on this side. So you see right there where it says, where are we? S. And you look for the decimal code, it says 83, T is 84, so we need to use these numbers to poke into memory to be able to read my name there. So I'm going to go ahead and change those so we can make my name appear instead of these funny looking characters. 214. We can just add another line in. We probably don't even need to. Let's leave that one in as an extra, I guess. Let's see. I'll just do 216 for 040. That should be good. Try to get it off the screen. There's 250. And there's 84, was it? So I'm just looking up those AXI codes from an email, so give me a minute to do this. Oh, not like an index. The first one's 83. This one's 84. So if that works correctly, this one time it should print my name, but it'll be farther off in memory here. So let's see. Let's double check it. 83 is S, T is 84, E is 69, V is 86, and of course we got our other E right here. So it looks like it's correct. So let's go ahead and run it. Let's see if it works. Well, I'm standing stalling for some time here. If you want to learn some assembly, I wanted to show this, and I was showing this in the original demo video I created for this series, but it didn't record correctly. I recommend this, highly recommend this book called Machine Language for Beginners. It's got some great starts for beginners in assembly here. This first example here in the book, it shows you a demonstration of the data statements that you can translate and understand what these data numbers are doing. And it kind of breaks it down in introduction, the fundamentals. In this page here, it kind of explains how the bits work in memory, how they're on and off, and how they operate, what a nibble is, which is half of a bit. And then it gives you some instructions here that you can kind of learn from. Maybe get a focus here. Right here you start seeing some load, wise, store. So it's got a lot of great examples here. And the instruction set here, I wanted to show you this. We'll get back to the program here in 1 second. Sorry about the detract there. Right here in the instruction you see where it says DEY, DEX, INX. So basically it's giving you an overview of how these instructions work and how you can get them working in an assembly program. A great start to learning assembly language. I highly recommend it. You can get the PDFs. I'll try to post the links online. In the meantime, let's go continue back and see how our program is doing here. So this was our characters. We left those in earlier. So as we scroll over here on this top line, eventually you should see some more characters. They're going to look different than these because I use different values, or they may not. It may be just different colors, but I'm going to see if we can get my name to appear on the screen here. So let's find out. Nope. It's right there. So you just seen it. It actually scrolled through memory and it showed up different characters. They might be in different colors here. Let's go back. These are in green. Oh, these are in green too. So basically it's not reading in the right screen codes or something. I thought those were the right codes. I must start at 33 or something. Hate to detract on this. I just wanted to show you. You can see that it's basically working. So whatever I'm doing there in memory, it's showing up on the screen. That's what's the whole point of that. So I guess I won't try to get my name successfully implemented in this video as much as it's hurting my pride right now. Maybe I'll just poke one line in S and just see if we can get an A to appear on the screen. Because I know the code for A. Let's go back down here. Set the single line. I'll set this one out farther even. Maybe 90. And it should be 33 if I'm not correct. And we'll cut one. We'll space them 2 apart. And then we'll do a different color. So I'm going to try to do 2, after you've seen those second line of characters as we scroll through further in the program, you should eventually see some more characters on the screen. And let's just test that real quick. Excuse me again for going back here a moment and kind of taking you out of sync with the program. I just wanted to show you that this is actually working. Everything I'm using these poke statements is entering what I need to show on the screen in memory. So let's just run that again. And hope I found that S, or the A, should be, it should show, I think I just typed in 2 A's there if I'm not mistaken. Yeah, I did 2 different colors. So they're basically doing in 2 different colors now, if it works correctly. Okay, so let's go ahead and scroll it. We've seen our first data. Our second data. Here we go. See the letter A? And this one picked up a red brick. So basically it took the color inverse for this brick. But we did find our A. So as you find the correct characters in memory, I could eventually put my name up here. I just had to look them up. I knew that 33 was the letter A though. I just had that one memorized. It starts from 33. 34 is B. 35 is C, and so on. Go back to where we were. Get you back on track here. This is basically what I was doing. I was just adding in these new lines here. So. Okay. This next line is not my own example. This is from the original author of the scrolling program. This is just setting up a paging area memory. I think this is where he's pointing to some of those pages I think you've seen vertically. Because we've already redefined and we've already changed our location for the pages where we want this to reproduce. And I'll show you where I was able to go ahead and manipulate the high and the low bytes, because originally they had this just showing a bunch of characters on the screen, or if you would, screen garbage, because it shows a bunch of letters, numbers, or whatever all over the place. It allows you to use it as a scroller. But I redefined those characters to look like something on the screen, and I think I mentioned earlier, I'll try to maybe even show that if I don't forget at the very end of this video, and don't run out of time here, and rerun the original example and show you how it compared to mine. And again, this is just intermediate, so it's going to run these locations a little bit faster. It's going to execute this code faster. These are not assembly instructions. These are just page, I think these are page increments or something. I don't know exactly what they're doing. And this is just positioning those messages you saw earlier in the screen. Phase 1 done. Number 6 is allowing it to print to the graphics one screen and higher, larger text. This is the display list here, and this is exactly where I wanted to show you. Actually, I've gone and I've changed this, I noticed. I'm going to change these lines here. So it makes sense. I was trying to move the memory around. These didn't work correctly. It was supposed to be 34, and this is supposed to be 34. So basically what we're doing here is we're creating the display list, and we're finding the high and the low bytes of where the screen memory is going to appear. So I have mine, if you saw me earlier changing this 34000, and I was poking in different values. I have mine starting here at 3400 and just scrolling through memory there. So it's picking up the high and the low bytes and setting them into memory. And this is just building them into character set as I demonstrated earlier. It's just reading this into this string. All this information you're seeing right here, this is exactly what this is doing. But this originally reads it into a for loop, which takes longer, so I just set up the immediate instruction to make it faster. And this was another way I was trying to go in and change the character lines here to be able to get the lines to read further down the screen. But when I tried to start covering more of the screen, So showing all that garbage at the bottom, it started messing up the screen, so I just took it back out. Okay, so I gotta relist this. And you see the phase 2 message comes in next. And right here, we're reading in what's called the vertical blank initializer. And this is just the main code. I don't know if I showed this in this video, but it's the my assembly of this whole program here. This was my example you saw earlier down here. And this down here, the vertical blank initializer, this is all their code being disassembled here. So it goes down here. Oh. Look at these pages held together. Down here, and it continues on over here, up at the corner here, all the way down through here. These are pull statements, basically setting up parameters within the code. And the parameters are what you might have seen earlier in a USR instruction. I don't have one on the screen, but you saw the V equals USR address FILLS, comma, this, comma, that. This is what the pull instructions are doing. They're allowing you to set up the parameters so that you can use the execute basic code directly within them. And this program just goes on and on. This is vertical blank routine. This is a bunch of my disassembly for it. Camera's not grabbing it. It goes on the back here. I haven't fully dissected it to be able to give you a full glimpse of what it does, but it's basically allowing the joystick scrolling to happen in the program. Now, some of the things I did have to change in this, because originally, the original program, for some reason, when you pushed the joystick to the left, it went to the right. If you pushed it to the right, the screen moved to the left. So I don't know why they left that in that way, but I had to go ahead and fix it. So when I disassembled it, I found it right here on this page. Maybe a little bit more advanced, so try to keep up here. See where it says right there, load 632, X, and down here it says and number 3, and then down here it says and, where are we at? Where is it at? Let's see, and number 3. My hand's getting so tired here. Oh, it says and number 3, compare, oh right there, it's compare number 2, compare number 1. Those are setting up the joysticks in areas in memory where this the control is actually happening at. So if you're adding and masking a value in memory, it's going to try to match and correspond to the individual bits for that location. I think it's 255 minus, well, I forget how that's calculated, but it's basically masking out. If you know how the AND instruction works, it basically masks them out and turns them into zeros. You have zeros and the ones or something like that for the two ones it finds in memory. It's just basically I've gone in and I changed those compare statements, I reversed them, and I was able to get the direction scrolling in the right way to make that simple for you. I can make things pretty technical sometimes, so excuse me. I just get carried away and I like talking about this stuff, but I think that's about it for the program. I'm sure you're done happy. It's already almost an hour and a half here. I'll hit a threshold. Down here is where I go ahead and I change the colors in the original program. They were defaulted to orange and red, so I've gone ahead and I've changed them. I think this is the blue or something. I don't remember what color that is. Let's see. 17. This is red right here. Is it orange or something? I don't know. I remember it was the green, maybe it was green or something. And this is the immediate instruction for this is how it goes ahead, and this is the whole instruction to go ahead and get the scrolling working in. So it's basically setting up the vertical blank here, or vertical blank here. This is the main routine that controls the joystick and everything. And this right here reads in the proper area for our display list, so it knows where to find the screen data to scroll through. And I haven't got all these parameters fixed out yet, but I have the code disassembled here, so I have to go over that later and figure out what that does. And this finally just reads the pages, which I still don't know what these values are doing, but they're down here further in the code. Well, I'm not going to go there, but they're basically reading in the pages in memory, which I think is controlling the scrolling vertically or something. And this is just setting up the character set, where to locate them. This is setting up the player missile graphic to position him at 128, so from 0 to 128, so he appears in the middle there. And go to 810. Notice it says go to 810. but it's not saying go to back here, which is our USR instruction. You'd be like, huh, how do I get this USR instruction to keep going when it's only going to 810? If you've ever watched my videos for scrolling and even the original one on my game design, I mentioned this mostly in the scrolling but also in the game design. This program uses something called a vertical blank interrupt, so it doesn't even need to only operate this one time, and it's already run intermediate in memory. So it doesn't need to be at this line, it only needs to execute it one time, and it's running through an interrupt every time it's finding the correct addresses in memory to locate it. So I'm sure that was a mouthful for you, but here's all the data statements. Here's the page I was talking about earlier. These are the pages, strings. I don't think that it says RAM page usage. Let me see. I noticed something about these values, that these are locating high and low bytes, because actually if you calculate this, I'm going to take you a step up here, but because I have familiarity with this, this is a 208, let's see, 208. I'm trying to find the high and the low bytes. Let me just look at my code real quick. I probably shouldn't try to figure this out when I'm telling you this, but I got one right here. It says 141, 5, 6, so it's I guess I'll have to go over this later, but it's basically finding the high and low bytes of where the address and pages is through memory. So let's go ahead and finish this one up because it's too long, I'm sure. Okay, so now we got the display list, and if you watch my display list videos and also my fine scrolling, I talk a lot about this. You just want to pay attention to this line right here. It says, where this number says 118. This allows both the vertical and the horizontal scrolling. And if you watch my fine scrolling video, I'll explain that a lot more, although in that video it does use 119. For some reason this one is using 118, which does both the same scrolling though. This is the vertical blank initialization. And this sets up where to locate the vertical blank at. I don't know what else this really does. It just sets up all the parameters, which I just showed you earlier in that USR instruction. And here's the actual routine. This is the joystick routine. I've gone in and I've changed these bytes. And I mentioned this in other videos, so excuse me for making this a little bit excessively long, but right here at the rows here, I think I have it on this one. Let me see. Did I even write them? Oh, yeah, I wrote them here in the corners. I found them. So anytime you're disassembling your code, to keep track of where the data statements are, you always want to write down, I always write down the line number, like 9030, 9040, and this is the assembly code. These are the data statements. So remember 9050. So these are these lines right here. So it's basically showing you where your code is going on and how you can go ahead and alter what you need instead of trying to figure out where is it at. You know, where's the joystick at? So it's a lot faster that way, I found it to be. I think that's pretty much it for the program. So certain. I'm sure you're probably glad that's over, huh? But since I am a little anxious here, I wanted to see if I can get my name to appear here. Going on an ego trip for a minute, excuse me. So 33 is the AXI character for my name. So let's see if I can calculate this. 3 minus 5. Oh, I'm going to put that in there. 18, maybe it's 32 plus 65. Trying to figure out where the S's and the T's and everything would be located. Plus 33. Let's see if the A is at 33. And I'm going to subtract this or something. I can't remember how to do this. I think this is it. Let's see. This is A. Doesn't look like A to me. Because we know our A is 33, not 32. So it might be 34 or 31. What am I doing wrong here? Let's see, 32 is 33. Oh, that's correct. So that's actually locating the A in screen memory. So all you need to do is just put in here my name and write down all the numbers, and I can get my name to properly show up on the screen here. So We know A is 33, so S is 51, so write that down here. T is 52. E, 37. V, 54. There we go. So if I've done this correctly, it should show my name to appear in our screen memory. I'm going to double check something here. I had that wrong, 37. Okay. Oops. I just created a new line. Hopefully I didn't erase anything important here. Yeah, just erase an anonymous data statement. I hope I didn't screw this up, but let me see if I can get it to poke in the memory. User's ego trip for a minute. I just wanted to show you that this does work. 30. If I've done that correctly, it should appear in memory. If that 51 hopefully was not a very important line. I'll double check that in a minute. So I'll double check my accuracy here. 51, 52, 37, 54, 37 looks good down here. I want to see where that 51 fell at. I think it just erased one of my remarked data statements. Hopefully it didn't erase anything important in memory. We'll run it and find out. Might just get an error message, who knows. And this should finalize everything. We just went over an hour and a half. Wow. Longest video I ever posted. It's going to take a long time to upload. So the third character, as we're moving over memory, you'll see the first one, and as I scroll over you'll see the second 5 characters. So the third one in sequence should say my name, if I've done this correctly. There's 1. There's 2. Should be over here. Yola! There we go. So I basically printed my name in screen memory. So that'll go ahead and conclude it for this video. And sorry if it's been excessively long. I just got a little carried away there in the end. But yes, you can see how scrolling works and how you can hopefully start setting up your own routines to work with the program. Now this program, if I can find it, there is a link online where you can get this program, but this is not the exact program I changed it to. So I don't have my code anywhere where you can get it online. I can just show you the original example if you want to work from that. If you are interested in learning how this works and getting this on screen, I'd have you probably post this somewhere where you can get to it. So I don't have I have a website where I could post it or something. I haven't got any requests like that yet. And I don't know how, since a lot of people use emulators, I don't know how to convert that into the binary equivalents that you need for the emulator. So I'd probably end up having to type it into an emulator and save it as I think it's called a binary file where people can upload it. So fortunately that's going to take me too long, especially going through this excessive program. So hopefully I'll find the original example and you can work from that and maybe use it as you see me scroll through this program and modify it to work for your own needs. So wouldn't that be cool to be able to set up your own scrolling thing? So anyways, if you're interested, go ahead and subscribe to my channel. I really appreciate that, and I'll get more Atari videos out there for basic. I kind of swap between assembly and basic, going back and forward. It's kind of, to balance out the equation for people. So thank you for watching.